I am Linda Rivera, RPI Alumni, and I'm here to tell you a little bit about myself. I am originally from Bogota, Colombia, and came to the States when I was a teenager right out of high school. And I have lived in the US ever since. Before going to RPI, I went to a community college in Connecticut, Norwalk Community College, and transferred to RPI as a junior. I was able to transfer all of my credits. I always liked math and ended up deciding to pursue a bachelor in electrical engineering, graduating with it in 2006. My original plan was to only pursue a bachelor, but I was encouraged by my mentors at RPI to go further and get a master's degree. I ended up staying at RPI to further my education. Right around when I completed my master's, also in EE in 2008, the financial crisis involving the housing bubble in the US was taking place. So I was presented with a choice of graduating and looking for a job in a challenging job market, or staying in school seeking a doctoral degree instead. I honestly didn't think I was suited for something like this in terms of skill or brain power, but at the same time, it was difficult to turn down an opportunity that I became aware of in Dr. Rich Radke's lab, which seemed to fit my background and previous research experience. So at the end of it all, I decided to stay, eventually graduating with a Ph.D. in EE in 2013. I was in school for a very long time. However, when I achieved that final milestone, I felt truly rewarded and proud that I had made it through it all. Yes. While I was a graduate student, I participated in a program called Teaching Learning Assistance, TLA, which was offered as a way to cover for room and board costs. As a TLA, I live on campus. I would tutor at the Learning Center and also run sessions for undergrads covering topics related to grad school, ranging from GRE info sessions, the process of becoming a PhD candidate, to answering questions like what is it like doing research? How do I get into a graduate program? And other subjects along those lines. That was a great experience because I had always enjoyed helping students understand complex concepts that I was familiar with. I am not sure whether the TLA program still exists at RPI, but if it does, I would definitely recommend it, as it gives you an opportunity to teach through tutoring, which in turn helps you find out if teaching is something you would want to do later on in your career. As a grad student, I also conducted research as part of the program requirements. I was initially very intimidated by the idea of research. I had always been good at solving problems that had an answer somewhere, whether it was the back of a book or exam solutions and such. But research was different. You were either trying to improve the solution for a problem that had already been solved, or you were trying to come up with a solution for a problem that didn't exist yet. This was daunting to me. Over time, however, I learned to trust the process and realize that solutions are not encountered overnight. Instead, it is through the progression of investigation and experimentation where a solution can eventually start revealing itself. You shouldn't be too concerned with the end result necessarily, but instead with taking quality steps that help you get there. New learning from the research process will forge the path forward. The breadth of knowledge collected along the way is what will support the conclusions you arrive at. Since I graduated with my PhD in 2013, I worked for United Technologies, which recently went into a merger with Raytheon Technologies. The latter is the name that was adopted after the merger. This is a big corporation with several business units. When I first joined, I worked for Pratt & Whitney, one of few jet engine manufacturers in the world. My first few roles were as a highly technical individual contributor, developing algorithms for advanced sensing systems in the F-135 military engine program. Down the line, I realized the great need the company as a whole had for modernizing their digital technologies. Over time, I started getting more and more interested in this area and sought out opportunities that would point me in that direction. In doing that, last year I accepted an opportunity with a group in Brooklyn called the Digital Accelerator, or DX, which has a mission of essentially, as their name alludes to, accelerate the innovation in the digital space for Raytheon. I am currently a technical project manager working on several efforts ranging from data science engagements aimed at developing predictive analytics to prevent engine related events to developing digital applications for the military business that bring efficiency to their sustainment operations. To me, EE is a field that covers a very broad spectrum. The BS degree itself gives you a strong foundation of math and physics, on top of which you build knowledge of analog and digital circuits, as well as linear and discrete control signals and systems. Once you have this base knowledge, you can choose to go deeper in a wide range of areas from microelectronics, circuit design, control system design and optimization to robotics and automation, or even image processing. With a foundation in EE, you can really diverge into several different areas career wise. Given that I've worked in such diverse areas while in school and also now professionally, I would say that the most important experience that I gained at RPI has to do with one, understanding of the foundations on which everything is built upon, and two, the actual process of solving problems, the method, time spent figuring things out, persevering to do so, and taking advantage of available resources to gain better understanding. The first item provides you with enough breadth of knowledge to grasp several technical fields you may encounter along the way. The second facilitates critical thinking, the ability to break a large problem into smaller tasks, executing through those, and crafting solutions, which is something you can apply to not just deep technical problems, but also higher level business ones that all companies encounter. I definitely see these elements clearly surfacing as I've advanced in my career. The process is the key of the learning. This is not something that is gained overnight. The development of these skills takes place through taking classes, solving homework, performing under the pressures of exams and presentations, etc. The EE curriculum offered at RPI, along with a phenomenal faculty, provides you with the tools required to develop in these areas. After obtaining my PhD, I knew I had the option of pursuing a career in academia as a researcher and eventually a professor. However, after having been in school for so long, I wanted to get experience in industry. I had never been fond of career fairs, but I reluctantly, with the encouragement of a school friend, attended one in the fall of 2012. During that, I met someone from Pratt& Whitney who took interest in my control systems background. One thing led to another, and within a couple weeks, I had a phone interview, which then led to a full day on-site one. The interview process was tough, particularly the part of it where I had to give a presentation about my research. I felt a bit intimidated in a room full of only men with backgrounds completely different to mine. At first, I didn't think I belonged to a jet engine manufacturer at all. My PhD research had nothing to do with this industry. To give you a bit of background on that, I did my research work in collaboration with Memorial Sloan Kettering Cancer Center, MSKCC, in New York City, particularly in a treatment area called intensity modulated radiotherapy, or IMRT. IMRT is used to treat different kinds of cancerous tumors by applying focused radiation to the cancer region while attempting to minimize impact to healthy tissues around it. Generating these treatment plans is complex and time consuming. The process involves contouring organs, followed by selection of the number of radiation beams to be used, and culminating in the optimization of the amount of radiation for a given beam to maximize the dose of the tumor while minimizing that to OARs, or organs at risk. The major complexity has to do with the optimization. When I came into the project, I expanded a methodology that had showed promise in the prostate side by a previous student to more complex sites, including the lung and head and neck. These regions present new challenges such as dealing with larger areas to be considered, like in the lung, to having multiple tumors, as well as tight regions in the head and neck with several critical organs to be spared. My work showed that utilizing an improved version of a constraint optimization, a nearly optimal treatment plan could be generated in a fraction of the time, and with minimal calibration needed by an expert subsequently. As you see, on the surface, this has nothing to do with jet engines. However, during the interview itself, as I was being asked questions regarding my research work by professionals that were experts in such a different industry, I realized that the key of what I could offer laid in the fundamentals of what I had learned, ranging from developing algorithms to optimize the health of an engine to understanding of how to work with large data sets. In the end, this rang true with those I talked to, and eventually I got a job offer. While at Pratt & Whitney, I worked briefly, a few months only, on the commercial side of the house, but soon after got an opportunity to work for the military branch. For a few years, I worked on developing detection algorithms for advanced sensing systems in the F-135 engine, which powers the F-35 jet. The end goal here is to detect engine issues before a serious safety event takes place, while at the same time minimizing the amount of times an engine requires maintenance, which for these jet engines is very costly. Within a couple of years, I moved from being an individual contributor to more of a managing role, in which I help teams move certain efforts forward. At the same time, I started communicating up to management on the status and progress of projects and putting together roadmaps for how we would accomplish our goals. Doing this type of work was not something I was actively seeking. It just started becoming apparent that I had some natural skills for communication between highly technical individuals and those who were looking at the higher level picture of things. I rejected this at first because it didn't seem to fit my background, but I also because I felt once again intimidated by it. But then I realized that this was both a challenge and an opportunity for growth. So I decided to embrace it and explore the possibilities. While doing this type of work, it became clear to me, as I might have mentioned before, that in order for these efforts to be truly impactful, there was a dire need for putting a stronger emphasis in modernizing digital technologies across the board. I started inquiring and following the lead to where these kind of efforts were starting to happen, which led me to pursuing an opportunity in the military engines aftermarket division in a team that was just being formed called Digital Strategy. The goal of this 5-person team was to, on one hand, develop pilot products to showcase digital technologies as a window into future possibilities, while crafting a digital strategy for the military business for the next 5 to 10 years. Quite a lofty goal. Once again, I was intrigued by the challenge. While working on this team, I learned about agile development, a method commonly used to develop software, as well as about open source tools and common industry frameworks for developing software products at the time. It was a great learning experience, which truly laid the foundation for the opportunity I eventually sought out at the Digital Accelerator, where I work now, where, as I mentioned, I am a technical project manager working on several efforts ranging from data science engagements aimed at developing predictive analytics to prevent engine-related events to developing digital applications for the military business that bring efficiency to their sustainment operations. It's been quite a journey for me, with a lot of unexpected twists and turns. I sure hope that continues to be the case as I continue growing and learning. That's one thing I have realized, the learning never ever stops. I had several memorable experiences while I was at RPI. The year when I first transferred was actually very stressful. Given that I came into year 3 of the program, I felt like I had little time to acclimate to the fast and challenging pace of it all. I was a bit overwhelmed at first, but when I got the hang of things, I figured out a method to the madness and I stuck with it. This was primarily focused on do your homework, spend quality time working through the problems, and when you've hit a wall that you absolutely can't break through, seek help, go to professor office hours, bounce ideas off of classmates, but always come in with concrete questions. To me, this meant I had really thought through the problem at hand and I was just missing a small piece somewhere. I found this thinking exercise was particularly useful when taking exams. It was as if I had been training my brain throughout, and when exam time came, a lot of the thinking was muscle memory, so to speak. Some of my fondest memories as an undergrad are of Professor Wozni, my control signals and systems teacher. He's an incredible educator. I love the way he explained complex concepts and the passion he had for them. I really felt like I had jumped into a new dimension every time I walked into his class. I learned so much from him. I very much cherish those times. And during my PhD, I couldn't have asked for a more amazing advisor, Professor Rich Radke. The way he manages his lab and his students is conducive to successful projects. While he runs a tight ship, he gives students room to innovate and be creative. He's incredibly supportive throughout the process, which you absolutely need to get a doctoral degree, because inevitably you will run into roadblocks, and having someone to back you up in those tough times is critical to succeed and get to the finish line. I think what I admire the most about Rich is his passion for what he does. What I remember most about him is his enthusiasm and joy for what he was doing at a given time. That has stuck with me as I evolve in my own career. It reminds me to analyze whether what I'm doing is fulfilling and consider what I might want to do next. I know I've mentioned some areas previously as it pertains to the education itself: strong fundamentals in math, physics, system design, critical thinking to solve problems. But one thing I haven't talked about, which, believe it or not, I consider a true asset, is communication, both written and spoken. You will have the opportunity to develop this skill while writing reports and giving project presentations. For me, however, the true learning and improvement in this area came while I was a grad student. It happened through the process of writing conference papers and, of course, the writing of master and PhD dissertations, which is something you need to dedicate quite a lot of time to. Ultimately, this all culminates in the oral dissertation to defend the doctoral degree. Preparing, practicing, and improving in presenting this material really helped me later on, because the faculty I was presenting to were not necessarily experts in radiation therapy. I had to find ways of explaining all of this to the audience to ensure that the technical work I did was well understood. It is basically a skill that allows you to tell a story that's engaging and clear, and which, depending on your audience, you can tailor in terms of dialing in the level of technical detail that's appropriate. I would say if you like math, enjoy solving problems, have a curiosity for how things work around us, then a career in ECSC could be for you. The beauty of getting this type of technical degree is that it allows you to grow your career in many different directions. At the end of the day, we are constantly changing and evolving. Over time, you might gain new interests or discover that areas that you never thought you would enjoy or would be good at can present themselves as opportunities. And if you decide to try them out, you may uncover how the degree you got in ECSC prepare you for excelling in fields of work you never even considered in the past.